Hi, my name is Ashvath, and I want to talk to you about water conservation structures. Making these structures like contour trenches allows the runoff generated from the plot of land above it to be collected with and allow some more time to infiltrate. Now, India has spent a lot of money, even if you just consider the Manrega scheme, on these efforts, soil and water conservation efforts. And their design obviously needs to be informed by the plot of land above it, but studies for this runoff generation seem very, very limited, especially in the Kumaon region. In this Himalayan region, the main source of potable water is springs, and any water that leaves the spring shed is not going to feed the springs. So that's why Chirag and IIT Roorkee, mainly Sumit Sen from IIT Roorkee, collaborated in order to conduct these rainfall simulation experiments in the village of Bina. With the support of the local villagers, particularly Puranguru and his family, we were able to conduct 55 rainfall simulation experiments over 9 different plots. In this image, you can see Jitendra Singh diverting the initial spurt that's irregular from the nozzle till the pressure shown in that dial there stabilized. The cups below that you see were for uniformity coefficient experiments. We wanted to test how uniform the rainfall was, and it turns out it's 87% uniform. These plots of land belong to 3 different land users that are commonly found within the region. So you have oak forests, you have farmland, and you have pine plantations or pine forests. And there were 2 different rainfall intensities we tested. We tested one for high intensity and we tested one for medium intensity. The high intensity was roughly 70 to 80 millimeters per hour, reflecting a really heavy storm, and medium intensity was 15 to 18 millimeters per hour. You can see the depths and durations of all of the events there where we were able to record the rain. What you'll note is that there are some events where the depth seems reasonable, but the event seems much longer, indicating not the same intensity. That is because there were electrical outages during the experiment. We continued them till our runoff stabilized. You'll be able to see in these graphs where there were electrical outages, you see those gaps. And lastly, there wasn't always some runoff, especially with the medium intensity nozzle. So that left us with exactly 31 simulations to replicate. The simplest model that we could, which was derived from the continuity of mass and momentum, assuming a 2D free surface flow. We use the method of characteristics as shown in this graph, taken from Sally Thompson's lecture notes. Now, we use Monte Carlo simulations to vary 3 parameters that go into this model. And in order of decreasing sensitivity, they are saturated hydraulic conductivity, sorptivity, and Manning's N. Here are the results of the goodness of fit. And you can see that for some plots, it's very remarkable that all of the saturated hydraulic conductivities seem to line up quite well, whereas for some, it's quite different. You'll also note that there are some bars underneath these graphs. These were saturated hydraulic conductivities measured with mini disc infiltrometers. And you can see that for a lot of these, tend to agree, which would be useful if we were trying to upscale this experiment. The next step would be to use this data and the model along with some design storms and formulate guidelines and potentially make a user-friendly software for estimating the runoff from these parcels of land. Thank you for listening, and if you have any more questions, you can reach out to me.